This is Neil Schneider from MTBS-TV at CES 2017. I'm really impressed by this machine I'm seeing behind me. To my immediate left is Brad Short, Chief Technologist of Immersive Technology. I hope I got that right.
It's a mouthful. Yes.
It's a mouthful. Come a little bit closer here, so you're in shot there. But you're the inventor of this, yes?
I'm the original inventor of Sprout Gen 2, which launched, I think it was 6 years ago now, or at least we started 6 to 7 years ago. We launched the first product 2 years ago.
Really impressive stuff. So can you quickly elaborate what Sprout is?
Yeah, Sprout, in its essence, is a dual-screen PC that allows a very immersive computing experience, which we kind of call natural user interface. So full touch-enabled, both screens, very tactile. But the unique and the reason I invented it in the first place was to be able to bring the reality and the real world into the digital world in an effortless, seamless transition. So instead of going to a camera or a smartphone, and it was getting easier, but I thought, why can't you just immediately capture things into a compute and digital experience, right there in the same kind of volume and area. So it has 2D capture and 3D capture that both can be digitized and being brought right into third-party apps.
Okay, well, words, you can't really express in words what this delivers, so we're going to do a quick demonstration, or you're going to do a quick demonstration of what Sprout is capable of.
Okay, so this is the new Sprout by HP Pro Gen 2, and it's an upgrade from the Gen 1. It has 2 touch screens. We've upgraded to a high-definition matte screen. That's a fully functional extended Windows desktop. And one of the key features of the new Sprout Gen 2 is that we're completely exploiting Windows 10 and third-party apps. So all the unique capabilities of Sprout can actually just work in concert with existing apps. So like here I'm showing a normal Windows file browser down on the mat in high resolution. We've also introduced an active stylus. So I can bring up, this is a Windows sketching kind of tool. So you can see it's a high resolution, pressure sensitive, 2048 levels Wacom technology stylus. The key kind of feature, unique aspect of Gen 2 though is we've developed a real-time 3D scanning technology. And so I can demonstrate that here. We've made 3D scanning now as easy as video, but we're combining high-res video, 2D photography. So in this case, I'll just do a quick demonstration of scanning this art project. And so I basically put it in the center, start the scan, and you can see it build up real time in front of you. And basically, instead of moving the camera around an object or placing the object on a turntable, I can just move it by hand. So we're doing real-time tracking combined with real-time 3D reconstruction, and we're superimposing the 2D images. And if it loses track, it just regains track. I'm ignoring my hands and fingers. As long as my fingers move, it tracks really well and then integrates out my fingers. And when I get it to a complete enough model where all the areas are covered and fully filled in, then the unique part is I can add the high-res imaging. So I hit Capture HD, and that's going to add a high-res 14 megapixel image over the top of the 3D scan geometry. So I'll do the back side, the left side, right side, the underneath side, and then let that rescan there. And then I hit finish, and then I've scanned this ahead of time. It takes about 2 minutes to process, but I scanned this ahead of time, and this is what the final image looks like. So you're basically combining high-res photography on top of 3D. So I can even see the details of that barcode sticker on the bottom. And I can see the mesh detail here, the triangle mesh that's created. So these files generated are standard OBJ files that I can import into any image editing, surface mesh editing software. We're seeing applications for like AR, VR, where you can import it into virtual for remote collaboration. We're seeing importing into gaming. We're seeing it in 2D design, where now you can have a 3D with high resolution color image superimposed. So I can drag and drop this into Photoshop. The Windows 10 Creator version supports 3D, which was announced, so I can drag and drop it into 3D Builder and other 3D. So we're really trying to make 3D a new medium more than beyond the engineering 3D and engineering for reverse 3D scanning for reverse engineering. And then some other examples. So this flashlight I scanned ahead of time. You can see the details we're getting here. So very accurate rendition. Let's see. This toy. So it can generate 3D with high resolution texture in a matter of a few minutes, where I'm not going to spend the time necessarily to generate this in CAD, which I certainly could do. But we see this just introducing a fun element to 3D, which is really going to introduce 3D to everybody, which was really the goal of Sprout from the original. Bring sophisticated tools that engineers or highly trained technical experts use, but bring it down to a user experience that's easy to do, that anybody can do, and we think that's really what's going to spark creativity. And ultimately, Sprout is a creative tool. It's a creative product for creativity.
So if I may ask, how detailed can it get? I mean, it looks pretty detailed here. How would you define how fine it can get?
So this type of scanning is getting down to about 1 millimeter accuracy. So it's not getting the super high resolution like the little texture in this handle. It's actually not in the 3D, but it's captured in the 2D. Now we do have, and this comes free with Sprout, it's a different type of 3D scan that uses the visible light projector that does structured light scanning. And that's based on our acquisition with David Laser in Germany. So we have this kind of quick and dirty, instant gratification, fun, but I can also switch over to our other application, which is much more professionals, and that gets down into the 10 to 50 micron accuracy, really high detail.
So this is really impressive. Can you quickly elaborate how it works? I see that there's projection, you got a display. How is the depth information being collected?
Sure, so for this technology here, we're using a depth camera that uses a fixed structured IR pattern. So it's projecting that, similar to what people would know as a prime sense or real sense or what's used in Xbox Connect. So it's projecting that dot pattern, and the camera is seeing the shift in that pattern. It's reconstructing in 3D. But then we have a 14 megapixel high-res color camera that you saw when I took the HT camera shots. It's now superimposing high definition, about 220 dpi color data on top of a 1 millimeter type data for 3D. So it's the combination of the photography with kind of the instant scanning that makes this almost a new medium. Maybe think of it as scanning objects for VR or gaming, where you really don't want heavy 3D graphic models, but you want something that looks really cool and realistic.
What's the going rate for this?
We haven't announced a price, but it's now a commercial. It'll be sold in commercial outlets. Gen 1 was a consumer, and we found it really resonated in commercial. Education, manufacturing, kiosks. We have a kiosk mode set up on this other Sprout. So it'll vary in price depending on the solution we offer.
Amazing stuff. Really amazing stuff. So what would you ultimately see coming out of this?
So we're seeing whole new types of medium being developed. It really resonates in education because kids' imagination is beyond ours. So we're basically creating these creative tools and putting them in their hands and seeing what they do with it. So currently, computing, in my opinion, is flat. It's a little too digital and flat, and you can become expert in that world. But what I want to see is what happens when you mix and bring physical world into that environment. And that's why we coined the term blended reality, which is blending things, not just going from one to the other, but actually superpositioning it at the same time. So what we're seeing is kind of 3D being thought is differently. It's now a medium. It's a way to communicate. So instead of just thinking I'm going to text, take a video, or take a picture, I think in the future what we're going to see is people are going to think about, hey, this would really be better if I took a 3D scan with a high-res photo. So it's almost like a 3D photo, and then sent that. And I think we're going to be seeing it posted to social media, and it just creates basically literally a third dimension to our communication ability.
So this, I think earlier in our conversation you mentioned that for now it's very much commercial. It's like an enterprise geared product, but I think in the future is more consumer end.
Yeah, I mean, we started consumer with Gen 1, but we saw it resonate in commercial fields like education, manufacturing, even standalone kiosks. And so I think it's going to pick up there because people in those fields, those kind of specialized fields, see and appreciate what these advanced, unique features that Sprout offers immediately. So they immediately apply it to their use cases. We're going to see that spread, and it will become more mainstream, and then we'll bring it back probably into consumer.
And one quick question for you. Something that really came out of this for me is I saw how easily you were able to scan objects in. Is this intended to be a natural balance point for 3D printers?
Everything we do in HP is designed to have an on-ramp and off-ramp. So at Immersive Computing Lab that I'm in, we're building on-ramps. So all 3D objects and digital content we create has full watertight 3D printable capability. It's very important to us that it's a round trip end-to-end ecosystem where 3D becomes digitized and then it can be output in 3D and then even come back in and be scanned. But we see two outputs, 3D printing, but we also see an immense opportunity in AR, VR, digital content, just using 3D for even 2D design. So there's just enormous potential.
Well, amazing stuff. I'm really glad I dropped by. It's a pleasure meeting you, Brad.
Pleasure meeting you. Thank you very much.
Good stuff. This is Neil Schneider at CES 2017. We will, of course, be back with more. Thank you for watching.